Number 27. An average of 1.7 hurricanes reach the United States each year. Use the Poisson distribution to find the probability that no hurricanes reach the United States in a given year. Okay, so the hurricane season can be thought of as the time frame, and then the Poisson distribution can be used to think of the number of hurricanes that make landfall during hurricane season. And for the United States, that's on average 1.7 during that season in the year. So we're going to use the Poisson distribution. We could use the formula for it. Probability of x being h is lambda to the h e to the minus lambda over h factorial. So you can use that to calculate the particular probability. And the question is asking, what is the chance that no hurricane makes landfall? So I'm going to use the table. So we have 1.7, and we need to reach 0. So 1.7 is the mean, and then 0 is first row. Okay. So that's the percentage of hurricanes having no hurricanes make landfall in a given year. Suppose you were interested in having the percentage of, so this is no hurricanes make landfall. So, and then suppose you want to know what the chance that at least one hurricane makes landfall. So that's saying there's one that a hurricane causes damage somewhere. Okay, so you're interested in this question. That's what you're trying to find. And this is not answered by the cumulative distribution function. So if you look here, remember this inequality is going the other way, and so we want what is down here. We want it for infinite because we can have a potentially infinite number of hurricanes striking, and so we want to know that there's at least one of them. So the cumulative distribution is not going to be able to calculate that for you, and it's not practical to use this one and have an infinite sum for it. I mean, you can do it, but you don't know when to cut it off. But there's a quicker way to actually do this. So just think about it. So we have something like this for a distribution, and you got a bunch of entries that tail off there. Okay, this one we can look up relatively easily. We just did it. That's quick to calculate. But what we're actually interested in is this value that I'm highlighting here. So this is for p of x greater than 1 is in that direction. But the one we can quickly calculate is equal to 0, or you could also do some other value. That's relatively quick to calculate. Okay, so how do we get that? Well, the area under the whole curve is 1 here, and so that's going to be chance that no hurricane hits plus the chance that a hurricane hits. Okay, this is the one we want. We know how to compute this one because we have it above, and we just got it. So if we subtract this from both sides, then we will get the one we want, the chance that a hurricane hits. Okay, so what is that? That is 1 minus 0.1827, which, when you do the arithmetic, is 0.913. So 91.7% chance a hurricane makes landfall in a given year. 18.3% chance that no hurricanes make landfall. So Again, this type of calculation here is important to be aware of, because this was relatively quick to do. If you realize that this is the picture here, and you have this value quickly, and this one, which is harder to compute, you can actually get by subtracting it from the area of the total curve, which you know is 1 because it's a probability distribution.